Okay, so moving on from there, let's talk a bit about hypotheses and theories, and then we'll be done with this section and move on to a bit more in specific designs and that sort of thing. Okay, so just one thing to clarify is that hypothesis is a prediction, but it should be educated. It should be based on a theory, um, higher research, stuff like that, right? And again, I want to emphasize that hypotheses um, should come before you collect your data, not after. That's not to say they can't be based on, or actually they should be based on prior work, prior data. But you specifically, hypothesis should come before you collect your data. Because we don't really go into things and say, well, I'm just going to collect this data and then afterwards decide, okay, you don't make a prediction before something happens. That would be, or sorry, you don't make a prediction after something happens. Make it before something happens. It's not impressive to say I can predict something after it's already happened, right? Okay. Um, so we talked a bit about theories here, but what exactly is a theory? Well, it explains how variables are related or impact one another. Um, and it tends to deal with more unobservable processes. So hypothetical constructs, like we talked about, stuff that you can't, stuff that you are actually interested in, but you actually need to translate into operational definitions that you can quantify, that you can measure. Um, okay. And of course, theories can be used or should be used to generate hypotheses. So, for example, maybe you remember, maybe you don't, classic theories about object permanence. This is the idea that before a certain age, children don't understand that objects they can't see still exist. So, say that again. This is that children think that, or they don't really understand how objects still exist, even if they can't see them. They think that what they can see is all that exists in the world. So, if you have a toy for them, hide it, they think, okay, it's gone. It no longer exists. They don't understand, okay, it's just hidden under this um, thing here, this sheet. Um, so that's the theory, and we're going to kind of use that as an example here. So, and just keep in mind that the theory is often misused. So a theory is, you know, an explanation, but once if it's not tested, then it's not a hypothesis. Okay, so what exactly is the difference between a theory and a hypothesis? Well, a theory is again going to be more complex, and it's also going to be more abstract. So it's going to be, it could involve observed variables, but it's also going to be a lot to do with unobserved or inferred variables. Um, Hypotheses tend to be simpler, so you're kind of testing one aspect or one assumption of a theory. Therefore, it's going to typically involve less variables than the more complex total theory. So, just to give you an example, it's been theorized that um, there's two routes to which you can read words. And in one route, you basically see the word and you recognize it instantly, whereas and that tends to happen for frequently encountered words, like say the. Whereas less frequent words or unknown words, you have to sound out kind of from left to right. So you probably had this experience where um, you see a word and you've never seen it before. You have to look at kind of go letter by letter and say and sound it out in your head. Whereas a frequent word like say the, you don't need to sound it out in your head. You just do that automatically. So that might be more of a broad theory. How I'm actually going to test that, you know, or make a prediction testing that would be the hypothesis. So maybe I hypothesize that some effect. I can't give you a great example here without going off on like a 200-page paper, but is going to be that, well, some effect occurs depending on the position in a word, or sound matters when it's indirect, something like that. I'll give you a better example in just a second. That was just one. Again, a big difference here is that theory is, again, more abstract, more about inferred variables, whereas the hypothesis is about the actual measured variables you're dealing with. It's concrete and specific. Okay. So here's an example. Let's say there's a good theory out there that when you're trying to solve a problem, if you're having trouble, it's because you get fixated on incorrect details. So, for example, if you're trying to solve a riddle, say, you might fixate or kind of get stuck on something that's not actually going to lead you to the correct answer. Call that fixation. I guess we don't call it that. That's just standard term, but whatever. And taking a break could help resolve these fixations. So taking a break from said riddle, you might be able to forget about kind of the earlier thing you were fixated on and actually get to the correct solution. But that's just a theory, right? That's a theory about why taking a break from a problem might help you solve it, because you can forget incorrect solutions that you were fixated on. A hypothesis, on the other hand, is how do we actually translate that into something measurable, something testable? So maybe I give people two 30-second attempts with a break in between to solve a riddle rather than one 60-second attempt. And I predict that the two 30-second attempts will lead to more riddles solved than single 60-second attempts. So again, the big difference, don't worry about all the details there, that's just an example, but difference here is that one is at kind of the experiment level of what am I actually predicting will happen that's going to support or not support my theory. The theory is the abstract. Okay? And again, notice how these kind of hypothetical inferential terms become concrete observable things. So taking a break, well, that's the two 30-second attempts versus the one single or the multiple 60-second attempts across, multiple 60-second attempts across each riddle you get, but it's only one attempt per riddle. Clarify. By the way, we actually do this experiment in my Cog Lab if you're interested. And then fixation, problem solving, well, that's the riddles, helping forget those fixations. That's kind of the inferred part. The fact that they are solving more problems is the more concrete observation that inference is based on. Here's another example. This is the theory of planned behavior. I won't really go into it, but it's just kind of a framework for how behavior results due to a number of factors like attitude, subjective norms, perceived behavioral control, and those all kind of come together into intention, which then influences behavior. So this is still just a theory, right? Because we're kind of dealing with these abstract terms like attitude, subjective norms, intention, behavior. How do we translate that into a hypothesis? Well, maybe something like this. So we figure out ways to actually measure these things, and we do predict that. I won't go into the stats here. That's not really the point, but attitudes are going to correlate with this, which is going to then correlate with that. That's again a hypothesis. Don't worry about the specifics, but that's a hypothesis because now we're dealing with measurable variables. Okay. Okay. So a few more things. We've talked a lot about the description, and just kind of keep in mind that actually we kind of covered this already, but remember a big thing in science is that it's going to explain the relationship between variables. It organizes and interprets research results. That's kind of the role of theory. So when you're dealing with the more descriptive part, we're just talking about identifying something maybe a problematic behavior, maybe a memory phenomenon, whatever it might be. But the next two phases, explanation and prediction, that's where we're actually going to explain the relationship, and that's where theories come in to kind of help us understand why that's actually occurring, and also then be able to predict it based on theory. I think I just want to really hammer home here that a very obviously important aspect of theories is that, can it be tested? Can they be evaluated? So I have about 50 theories in my mind for how memory works, but I've only been able to put about 10 of them into figure out 10 ways to actually test them. So all the theories that can't be tested or I haven't figured out yet, those will have to wait till I can figure out a way to test them, right? But when you have a theory, it's great to just have a theory, but you need to figure out if it can be tested or not. If it's impossible to test, then it's still a theory, but it's not, it's not a worthwhile theory because, again, it can't be tested. Let's see. So theories obviously should also generate new research ideas. Again, just building up this idea here about whether a theory can be evaluated or not. If it's a good theory, it should be testable, leading to new research ideas. And it provides predictions that are tested empirically. And this is known as the heuristic value of a theory. So if a theory is kind of either to the point where it's pretty not proven, but accepted enough, there's not really any research going on about it, it doesn't really have any heuristic value. If the theory has been, again, not disproven, we don't really like that. We don't like that word prove. Then it's also kind of lost its heuristic value because it's not generating any new predictions that can be tested using empiricism. Okay. And that's kind of another process here that I want you to kind of always have in your mind and consider before we get into more specifics is that, there's kind of a constant back and forth between theory and data. It's not like it's not a clear, or it is a clear, but it's not a set in stone temporal sequence. It's again back and forth. So new theory is going to result in new data, or at least it should. The new data is going to lead to modifications of existing theories. Let's see. And that's kind of also the progress too, is that things go through rigorous testing and modification until a theory is either rejected or so well understood that it no longer has heuristic value. So again, this is why we don't say prove, because one study doesn't rule out a theory, but basically, you might have a theory where something is influencing memory, and you find a study that says, well, that's not the case here. It's not the case in this particular situation. Well, that doesn't disprove the theory, because again, we don't use the word proof, but it does open up some new questions that says, well, maybe it doesn't work in this situation, or maybe it doesn't, doesn't apply to certain exceptions. And if you kind of keep discovering findings like that, like it doesn't work in really any situation, well, then the theory is kind of rejected and it's not really useful anymore. So that's kind of the point, though, is just that it's not an all or nothing thing. Like theories can be modified, or they can, slightly, but still be useful, or they can be modified to the point where they're basically no longer useful. They lose their heuristic value, and they're more or less rejected in favor of a totally different theory. On the other hand, if data continuously supports a theory, or it's modified to the point where it's fitting all data patterns, then it also might not have any heuristic value and not really require any further investigation. Okay, so let's talk quickly about some of the strategies for testing theories, because theories are super important and kind of spawn research. So one strategy is known as the confirmational strategy. This is just a straightforward test of a prediction from a theory. So if something is occurring, if this theory is correct, then it should lead to, and introducing this manipulation should result in Y. Okay. Let's give an example. So we talked about object permanence. This is again the idea that before a certain age, children don't understand that stuff they can't see still exists. They think only what they can see is what exists. So let's say you have their food or something they like, or a candy that they like. Well, if you hide that from them, so you put it under a blanket or something, will they look for it? Or will they not look for it below a certain age? This would be confirmational because you're looking at, well, if they do understand that the toy is still there, or sorry, the candy is still there, they should go looking for it. On the other hand, if they don't, then they shouldn't go looking for it because they don't think it exists. But again, this is where we don't say prove because you don't know what other factors could be going on. We want to try to account for these factors, but it's not always possible. So, for example, let's say maybe they smelled the toy or the candy rather, or if it was food, they smelled it. Maybe they just didn't actually want it that badly, so maybe that's why they didn't go looking for it. Again, these are just examples of how we don't really prove things because there could always be other explanations within our experiment. Another strategy is disconfirmational strategy. So this is kind of just the opposite. So this is when if a theory is correct, then they shouldn't do this. They shouldn't, or this should not occur. So an example might be if we recognize words based on their purely on their visual shape, known as their orthography, well then introducing some sort of sound should not impact them. And if it does, well that's disconfirming the theory that we recognize words based purely on their visual characteristics, because auditory characteristics are having an effect. So that would be an example of disconfirmation. So again, if the theory is correct, this should not occur. And if it does occur, well, that argues against said theory. Okay. And again, this kind of all ties back into the idea of falsifiability and can the theories be confirmed or disconfirmed? Not proven, but at least supported. So I'll put the extra credit thing separately, but again, think of Freud, where it's like, how do you possibly disconfirm all these theories about unconsciousness? Because if it's unconscious to the point where it can't ever be articulated or measured in some way, it can't be supported or not supported. So it's not useful. Okay, the last one is the strong inference theory, or rather the strong inference strategy for testing theories. This is where you design an experiment, and if the results go one way, it supports theory A. If it turns out the other way, it supports theory B. So one example would be the contact comfort classic experiment. So there's this discovery that, not surprisingly, young, I think they've done it with babies, but also monkeys more so. Um, they obviously are very attached to their mothers and they don't want to get far away from their mothers. They kind of cling to them, not surprisingly. But a question is what is causing this? Is why are they attached? Is it just food because their mothers, of course, feed them, or is it more to do with comfort? And kind of the contact and the feeling, comfortable and warm part. So where they tested this was they gave monkeys two choices. They could basically crawl into one of two cupboards, and one would be this kind of uncomfortable metal thing that they could still get milk from. The other would be this warm, fuzzy thing that did not feed them at all. And what they found was that the monkeys would sometimes go, get some food, but in terms of where they just wanted to sit and rest, they'd always, cling to the comfy part. So that suggests that it's not really the food that's causing the attachment. It's the comfort part because they go to the food occasionally, but when they're just, not currently hungry, they want to be comfortable. So it's comfort that's causing the attachment more so than the food. This is again this would be an example of strong inference because we kind of infer from this that if because they chose the comfortable option but not the food option, it is the comfort that is attracting them. Okay. So just to foreshadow for the next topics, we're going to talk about correlation and experiments. This is a very essential topic that you really need to understand because it's a big distinction and sometimes you forget the difference. So again, we'll go over all this and why next lecture, but this is when you measure two or more. Correlation is when you measure two or more variables. Look for a relationship. Experiments are just when you put people into actual conditions or groups and you manipulate a variable. So we'll talk about that next time.